In this video, we are going to do looping roller coaster problems. So Sheila is riding the Demon roller coaster ride with a tangential speed of 13 meters per second. The turning radius of the loop is 12 meters. Sheila is upside down at the top of the loop and right side up at the bottom. We want to determine her normal force at the bottom of the loop and the top of the loop. So this tangential speed here, that's the constant speed that she's going around the loop with. And as always, we'll start by visualizing this. So here is Sheila at the bottom of the loop. We're imagining that she is going counterclockwise. So what forces are acting on Sheila? So there's the normal force and the force due to gravity. The force due to gravity points down. The normal force from the roller coaster cart on her acts upward. Remember, there's that centripetal force that's caused by other forces. Centripetal means center seeking, so that centripetal force points towards the center of the circle, which in this case is up. And that centripetal force caused by other forces would be the normal force minus the force due to gravity. So Fc equals Fn minus Fg. And that is equal to mv squared over r. So we can say that Fn minus Fg equals mv squared over r. And we can replace Fg with mg. At this point, we can start plugging in numbers that we know. So Sheila's mass is 62, g is 9.8, v is 13, and r is 12. And we're looking for that normal force. So if you just solve through the algebra, you will get that the normal force is equal to 1,480.767 newtons. Now, in this case, the normal force is greater than Sheila's weight. So why is that here? Well, that's because the normal force here isn't just holding Sheila up from falling through the floor of the roller coaster cart. It's also causing her to accelerate towards the center of the circle. That's that centripetal acceleration. Also, another point here, the mass does matter here. We did need to know Sheila's mass in order to solve this problem. And the reason why is if Sheila had more of a mass, there would need to be more of a centripetal force acting on her in order to maintain that centripetal acceleration and get her to go around that circle. Now we also want to find her normal force at the top of the loop. So at the top of the loop, both the force due to gravity and the normal force are pointing down. So the centripetal force, the center-seeking force, is also pointing down towards the center of the circle. So in this case, the centripetal force is Fn plus Fg. And that would be equal to mv squared over r. Then from this step, we can replace Fg with mg. And at this point, we can go ahead and plug in numbers. And we should get that the normal force is equal to 265.57 newtons. In this case, notice that the normal force is less than Sheila's weight, and that's because her weight, or the force due to gravity, is always already causing some of that centripetal force, so the extra little force that's needed doesn't need to be that much in order to maintain her circular path. So hopefully you understand how to do looping roller coaster problems now. Remember, it doesn't necessarily have to be a roller coaster. It's just anything where it's going like that and then ends up upside down at the top of the loop.